First, one participant wears a bilateral hip exoskeleton developed from CPNX. The exoskeleton adopts bilateral direct drive hip actuation and about 2.9 kilograms. Mechanical structure includes waist orthotic, thigh orthotics, and AK60 actuators. Waist orthotic stabilizes pelvis and supports hip module alignment. Thigh orthotics transmit assistive torque to lower limbs. AK60 actuators generate bilateral hip assistance during walking. LMUs measure hip angles at 100 Hz. Controller runs real-time assistance control. Wireless transceiver supports data communication. Battery supplies power for untethered walking. Measured hip angles enter our EMG-Observer-Driven Assistance Framework, EOAF. EOAF then generates online hip assistance commands. The participant then performs a ramp walking test. From front view, walking posture and step transition are clearly shown. Gait remains continuous during inclined walking. No visible interruption occurs. Rear view shows bilateral motion following. Hip modules and thigh orthotics move with corresponding lower limbs. They follow alternating swing and stance phases on both sides. Next, close-up views from left and right sides show hip motors and their coupling with lower limb motion. During ramp walking, motor modules stay aligned with hip joints. Thigh orthotics move with corresponding legs during hip flexion and extension. Motors execute real-time assistance commands based on user hip motion. No obvious delay is observed, and no visible mechanical interference appears. These close-up views further demonstrate bilateral motion following. They also show effective assistance execution at hip joints. Finally, assistive torque profiles of left and right hip joints are presented. Shaded region marks the initial stage without assistance. During this stage, commanded torques to stay close to zero. After assistance is activated, torque curves change clearly. Responses shift from an initial flat pattern to periodic gait-related variations. Left and right torque profiles show alternating patterns. These patterns match bilateral hip motion during ramp walking. Positive and negative phases correspond to different phases of hip movement. At the same time, generated torques stay within the preset safety range of plus or minus 10 Nm. This indicates that online assistance remains properly bounded. Overall, these results show that our EOAF can generate assistive torque for bilateral hip assistance during walking.